Hello and welcome to UNI.MINDS Festival, and thank you for choosing this parallel session, Artificial Intelligence. My name is Dominik and I'm very pleased to be chairing this exciting session, Artificial Intelligence, which will give us an overview of some of the hottest topics in this field with research and solutions happening in Slovenian research labs and tech companies. The event is organized by knowledge transfer offices of University of Ljubljana and University of Maribor in collaboration with our industry partners and supporters from the innovation community. The main partner of the event is Novartis in Slovenia. Also, this festival would not have been possible without the support of the Republic of Slovenia, Ministry of Education, Science and Sport, and the European Union under the European Regional Development Fund. In this parallel session, we will give a snapshot of competences, innovative projects, and good collaborative practices in the field of artificial intelligence. Joining us will be 8 speakers: Daniel Skočaj, Žiga Emeršič, Marko Šikonja Robnik, Marko Munih, Niko Herakovič, Aleš, Mihelič, Lucija Brezočnik, and Matej Guid. Now, not to steal any more of the precious time we have, I'm happy to present our moderator, Boris Tergol, a true AI hero. He is currently head of AI at Comtrade Digital Services, a provider of software engineering services and solutions. He held various research positions in both academia and industry. He serves as executive board member of the initiative AI for Slovenia, and is also a member of the AI top team advising National Standards Authority of Ireland. Also, he is one of the mentors at Textile's Montreal AI Accelerator. Boris, please, the stage is yours.
Hello, everyone. Thank you, Dominik, for this introduction. Also, welcome all attendees to this parallel session. So I think it will be a great way to get some insight into quite the different branches that are being developed in AI, and what some excellent Slovenian researchers, both in academia and industry, are doing in these areas. Let me basically just go to introducing our first speaker, since I want to have a bit more time for the debate in the end part. Let me give word to Daniel Skočaj, who is an associate professor at Faculty of Computer and Information Science at the University of Ljubljana, and also head of Visual Cognitive Systems Laboratory. Professor Skočaj,
thank you.
Welcome.
Thank you. So I will present a couple of activities in our lab, basically where we work on computer vision, embedding deep learning techniques in computer vision, basically for solving different problems. So we know that there's a lot of debate about data. We know that we have a lot of data around, and that machine learning is the right solution to extract the useful information out of this data to provide several solutions to different problems. And when these data are actually images, machine learning works in the framework for computer vision providing these solutions. And we did a lot of applications out of our research that I want to mention in a number of projects that we actually did in a couple of last years. So if you're able to see this video, you can see a number of applications basically that can be achieved, like visual tracking, like object detection in images or in videos. Visual inspection is powered by visual computer vision. Vision in robotics, let's say for navigating the autonomous boats. Image enhancement in mobile phones, for instance, is driven by computer vision. Tedious tasks such as counting those numerous white dots can be easily done by computer vision. You can turn off your mobile phone into a powerful computer vision device, since you have a good camera and a computer. Vision in robotics is present everywhere. So there is numerous possibilities that can be achieved by applying computer vision techniques, and this is basically what we are doing. Cutting edge research to provide new solutions for computer vision, deep learning, and cognitive robotics. I will just present 2 of them since I don't have a lot of time. The first one is visual tracking. So we developed very great trackers, basically, I would say, that can then accurately track, segment basically the objects in the video stream. Even if the objects are lost, you can redetect them again, and you can imagine a lot of applications of this useful. The other application I would like to mention is visual surface defect detection, where we developed a model that can train from the number of images, the model that can differentiate between good and bad products, for instance, in this case. It can determine whether an object contains defects or not using deep learning. And one of these applications is seen in this video here, where the system can automatically count the dents on the car body and actually can automatically fill in the damage report. So, and we are also going a step further. So from supervised to unsupervised approaches, where you don't need the defected surfaces, you only need a good ones in order to learn what the consistencies within the data is, and consequently then detect inconsistencies as a defects that can be seen in the image below. So I don't have more time to go further. We also developed different applications like classification of blanks to different categories, traffic sign detection, the data image anonymization, semantic edge detection, and so on. So there are numerous possibilities, and I strongly believe that computer vision, deep learning within AI are really key enabling technologies. So it matured during the time. Computer vision became very robust. It's very widely applicable across different disciplines, and I really see a lot of opportunities for further application of that. And I strongly believe that there is a high possibility to strong collaboration between academia and industrial partners. So we in academia, we have a know-how how to do it. In industry, there are several needs to use these methods, and working together, I really believe that we can make a breakthrough in several problem domains.
Thank you, Daniel, for your presentation. So as you've mentioned, deep learning can really be an enabling technology for many different types of products. So my question would be, one common critique of deep learning is its requirement of really large data sets, and also the problem where when we move from the kind of research setting to a practical application, that we are facing this fat tails effect, so that we are basically facing some events that were in no way, for example, presented in our initial learning data. So what is the progress in this area? How far along are we in this?
Yeah, so I mean, this is definitely true when you have data-driven approaches. They are driven by data, right? So if data is not good enough, then you cannot expect to have a good solution. So definitely the data that you have has to cover the space of possibilities that can emerge. So if the data does not, that you use for training does not represent well what can be happened in reality, then the method, that the module that you'll develop will not work good enough in reality. So a lot of time also when we collaborate with companies, a lot of time is spent on initial stage, right? To preparing a useful data can be used, that can be used for training the model. So one way how to get over it is, so getting the data is not a problem, right? So you can get tons of data. Even companies, they can, provide you as many data as you want. The problem is that standard supervised deep learning techniques, they require a lot of labeled data as well, so that you say, this is good, this is not good. And in companies, there is often a problem that you can't really get a lot of bad data because, the main purpose of the company is not to produce a lot of defective data. And that's why we also shifted recently in the direction of unsupervised learning in the sense that for training the model, you only need the good data. This is what I mentioned before and showed one image. So that you're trying to learn the consistency only based on the good samples, regular samples without any defects, and then to determine what the defects are based on the deviation from this regularity. So this is something that could be, I mean, this is a holy grail of computer vision in the visual inspection area. And I think this is a good way to go, right? We really got quite very nice results recently, and at least to make that part of the annotated data that you need smaller. So probably just get rid of it is not currently it's not an option, at least not for every case. But even if you decrease the amount needed, is a huge step forward, and this is what we are currently doing.
Thank you, Daniel. And since we have to keep on track with the time, let me welcome our next speaker, Žiga Emeršič, who is a researcher at Faculty of Computer and Information Science of the University of Ljubljana as well, and a member of a computer vision laboratory. So welcome, Žiga, the word is yours.
Thank you. So first I have to say that today our head of the lab should be present, Peter Per, but unfortunately he has other obligations, so that's why I'm stepping in. So biometrics is essentially observing and analyzing some physical or behavioral properties of individuals. Now the question is, how do we do this automatically? So how do you make computers, if I can say that, to recognize individuals or to predict something regarding those subjects present in the images? And also, that's not enough. We also need to be capable of extracting individuals from larger images. So for example, this crowd here on the left, we need to be able to somehow get that person on the right, out of this and then continue with this traditional, let's say, biometric pipeline. So in our lab, this is what we mainly deal with, but of course from the research perspective. So when it comes to the industry and companies, this collaboration, we started focusing solely on consulting companies, regarding the products they want to incorporate or plan somewhere and so on, not the actual development. And the main reason for this is biometrics in its essence is very very specific topic. We have personal data, data that just cannot be handled just like that, let's say. We help companies to get approval or productive rejection from the information commissioner. So that's what we are focusing on with our legal colleagues, of course, because it's always this computer vision aspect is almost only half of the story. But to get the grasp, I mean, to give you the perspective why this is such an important or difficult data to work with, is just this question: what can we use to recognize individuals? It's not only faces and fingerprints that we immediately think of and use every day, in our mobile devices and so on. It's also part of faces. It's also parts of eyes. We can use sclera with blood vessels. We can use periocular region, something that is especially fashionable, let's say, now that we are wearing masks. And also, the way someone talks, the way someone walks, the way someone opens the door, or the way someone types, all of that can be used to predict someone's identity. Of course, not all of those are equal, but if you combine, different sources like that, you can arrive at a pretty powerful tools. And to conclude, it's not only identities. It's not who that subject is. Is that person who is claiming to be? It can also be, some advertising task of, just counting how many male subjects were there, age groups and so on. So that's it. I hope I got you interested and got this idea planted in your mind. So, just, how many different sources of data we can use.
Thank you, Žiga. Thank you. So I'm also aware that you're doing some research in your laboratory that's in a way contrary to identifying people, but it's actually meant to protect their privacy. So maybe you could tell us also some few words about that.
Of course, thank you. Excellent question. So that's de-identification. It's actually the quite opposite. So if you imagine having a video of, let's say, a group of people, right? So we have TV show, you know, I'm making this up, this scenario, but let's say you have a TV show and a large audience in the back, or that's somewhere on the street. And typically what you would be forced to do is, you know, put black boxes on those faces. But the question is not only, I mean, the problem is not only that this looks weird and, you know, it's not pleasant to watch if you have a large amount of moving black boxes, but also you lose some useful information that did not contain identification information, let's say, so identity information. For example, you have a video where, you know, someone is smiling or crying, and you put black box on top of that face or blur it, you lose that. So the idea behind de-identification is either just changing faces, you know, just a tiny amount so that no one is able to recognize those person, while still being able to recognize poses, you know, and oh, is that person crying or laughing? And that's essentially the goal. And Blaž Medin is dealing mostly with this in our lab, it is very interesting topic. It's really the opposite of what we are usually trying to achieve.
Yes, and really also something I think that, you know, more people should be aware of, that it's something that it's happening.
I agree.
So always AI can be used for one purpose or for another. So thank you, Žiga. And let me announce our next guest, Marko Šikonja, who is the professor also at the Faculty of Computer and Information Science of University of Ljubljana and head of Artificial Intelligence chair there. So welcome, Marko. The word is yours.
So thank you. Thank you for introduction. So what I'm going to speak today is about cross-lingual technologies and opportunities which they offer for the small languages like Slovene, but also for many other languages which we can work on when the companies in Slovenia can work for. So when we are speaking about language technology, we are mostly in the AI sense, we have in mind what is called semantic language technologies. And even if we are not aware of that, we use them every day. For example, we communicate with our mobile devices. We do the search with these sort of technologies. We have all sorts of digital assistants which are coming now in and which will be really important in the future. Intelligence cars, we will communicate with them. Kids, they are engaged in electronic toys, household appliances, machine translation is really kicking in. We do automatic translation to reduce the burden of too much information, question answering, but as we will also see today, we have writing aids, and all this was happening. It's like a huge progress, happened in the advent of deep neural networks that we heard today. And the enabling technology for this were actually the embeddings. And this also strongly affects all the less resourced languages because, yeah, we all know that we have great applications in English, but what can we do for the languages we use daily? So as I said, the embeddings, that's the way how to represent, let's say, words in some numerical form, which can then be processed with these neural networks. So you can imagine like each word is mapped into some vector, and that all the words in a language form a sort of a word cloud, and we then play around with that word cloud and do different things with it. So how it works really, how this cross-lingual transfer works, how can we, for example, use the knowledge collected for the English to apply it to the Slovene? So let's suppose that we have, let's say, two sentences. Let's say that we are trying to do some sentiment or news analysis for the news, for example. So, for example, we have like the English sentence, the president announced today, and each word is transferred into a vector. And this is a gray vector because this is an English word cloud. And then we have the same sentence in Slovene, and because this is a different word cloud, it's in a violet word cloud, violet vectors. Now, we have lots of data in English, but we can map these sentences into the same numerical space. So we can align the English vectors with the Slovene vectors, and they are now both residing in the green space. And so if we learn now a deep neural network on the English, we can easily transfer that trained network, for example, for the news categorization or for the sentiment prediction into Slovene. And because the input is the same, the input are the green vectors, this model will now automatically work also for the Slovene. And this is what is called cross-lingual knowledge transfer. And this is a sort of the Babel fish for machine learning models. We can basically train them on a higher resource language like in English, and then transfer them to less resource language like Slovene or Croatian or whatever. And one of the ways how to do this are so-called multilingual BERT models. So BERT models, this is like the state-of-the-art models in the machine learning nowadays for the language. They were, for example, trained on 104 languages simultaneously, including all the European language and Slovene. And that means that if we train models on higher resource languages, it's quite easy to transfer them to the less resource language. And these models are really very good at language understanding tasks. So I said, for some languages, I mean, it makes sense that we build such models even more focused. For example, we have built BERT models just for the Slovene, Croatian, and English, which enable the transfer just between these three languages. And it even works much better than this more general 104 languages multilingual BERT. And this is like a huge potential for cross-lingual transfer and also for multilingual applications. And this is what I would really want to emphasize here. So there's AI, natural language processing, is very strong in Slovene, and it's easy to expand the market. So why would we stay just in Slovenian, which is a 2 million people market and maybe too small for development of, let's say, really great companies? We can reach out and we can use these multilingual transfer opportunities to do that. So yeah, that was my message, boys.
Thank you, Marko. So, like you mentioned, this BERT architecture, which is basically a part of the wider transformer architecture of neural networks. So my question is, how do you see the potential of this type of embeddings also to be used in other domains of data, like, for example, images or even something else?
Yeah, so this architecture, so this neural networks BERT, which I mentioned, is built on a relatively new architecture. So it's called transformers. So transformers are sort of neural networks where we add much more memory into them. And that memory can remember things which happened in the past, like, for example, in the previous sequences, in the previous, let's say, in the previous text and so on. So yeah, it's a way how to make neural networks even stronger. And of course, people have tried that. People try to do that, especially in the time series data. That's very efficient, but also in the things like video and imaging. But this is maybe a more general perspective of AI. How can we move away from those narrow models which solve small problems very well? How can we, let's say, make them more general? How can we integrate more knowledge? And there are, of course, several attempts how to do it. And I think that all the world is trying to see something really intelligent. And we actually, all the researchers are trying to pump more knowledge in and more common sense into these sort of networks.
Thank you, Marko. Let me invite our next speaker, Marko Munih, who is a professor at Faculty of Electrical Engineering at University of Ljubljana and head of RoboLab there. So Marko, the word is yours.
Yeah, thank you very much. I hope you can see me. Now this can you see my screen properly?
Yes, it's in full screen.
Yeah, thanks very much. I don't know how the video will run. I apparently didn't click the optimize for video. I don't see where to do that now, but I will just proceed this way.
Okay, or maybe you can just stop sharing and repeat all the procedure.
Stop sharing again. Okay, stop share.
And just select the optimize. Yeah.
how to optimize that now. Optimize, okay, I have it. I have it. Like this. Can you see that video now? Can you see the screen?
We can see the presentation.
Yeah, very good. So I would like to invite you to make a few steps with me into collaborative robotics. We have collaborative robotics center at our faculty in our lab for robotics, and let me guide you through a few things that are linked to the collaborative robotics. Now, the collaborative robotics have such kind of approach that there are 4 collaborative use operations which are defined. And these are safety monitored stop, hand guiding, speed and separation monitoring, and power and force limiting. Now, what this means? The safety monitor stop means that usually when the human is approaching close to the robot, then the robot stops. Now, next thing, hand guiding means that you are teaching the robot not by clicking different things on the screen, but by grasping and moving the robot around and then memorizing the point. And speed and separation monitoring, it's another step in the safety. And this means that the robot is following the environment and is then trying to also calculate what is the safety velocity and safety distance to the human. And you, of course, you are considering that in the robot control. And one of the next points is force and power limiting. This means that the robot should not be able to act on the human with too big force if the impact occurs. We have a number of points on the human body that require or allowing more or less force that is happening during the impact, if that happens, of course. Now, the consequences of all this are numerous. First of all, increased human and robot efficiency. Then simplified programming. You can imagine that hand guidance is exactly in that direction. Of course, the robots, which are safe in a principle, they don't require fence anymore. So we have space-saving flexible deployment, applicable to small and mid-sized manufacturers. And because of that, we have also increased return on investment. So that's important. And the further effects are that we have improved ergonomic working conditions. We have shorter cycle times due to concurrent operations. We have gradual or partial production automation. And we have flexible coverage of production capacity. And of course, efficient use of the space, which was already mentioned before. Here you can see in a video a few examples how these robots are constructed and how these robots are also included into environment. We have some examples how this could be then applied together with the human. You can see impact sensing, you can see collaborative common operations. Of course, the applications which are running here in the middle are different and numerous. Screw driving is one of very interesting things because you have a sharp tool, which is a screwdriver, and you have a collaborative robot, and all together should be collaborative. So that is kind of approach that is coming. That is approach that we have included it into the Collaborative Robotics Center. This means that we formed an environment, a number of robots was joined in a common space in such a way that they can even share the workspace, or they can share the workspace with the humans. As a demonstration site on one side, as a learning, studying side, and as a research side for the academia and for the industry. Here on this picture, you can see some snapshots which are coming from our lab. UNI collaborative robot, 2-arm robot, and then UR collaborative robot, a Japanese Fanuc collaborative robot with the green color, the Yaskawa, a little bit bigger robot, and here is the German DLR or Franca robot. In the background, you can see some classical robots. Here in the background is Yaskawa, classical robot, again, classical ABB robot, and classical Epson robot in the background. What we also added here is during the summer, of course, and because of the COVID period, we added a remote access to all these devices. So at the moment, the students are sitting at home, and the cameras, of course, are also in this area around. The students can have a look what is happening in the work area of the robot, and they have access to the robot controller, and they can work remotely. And that's also valid for some of our other partners. Of course, all this would not be possible without great support of our environment. This means, first of all, of course, university, and then a number of other partners, which are including Slovenia Research Agency, as well as commercial partners as Collector, RLS, and TPV Group. We have a number of collaborations on the robotics side, which are offering us the latest software and hardware achievements, and these include Yaskawa, as I said, Franka, Emika, Inverser Robots, Fanuc, ABB, and Bekov is our classical supporter. So this is just a quick step into the collaborative robotics. Of course, we would like to develop that further. Of course, we have a number of projects that are happening here. Maybe some next time description about that. Thank you.
Thank you, Marko, for your presentation. So just one question from my side. In regard to collaborative robotics, there is really a lot of focus on industry, or should I say manufacturing applications. What is your take on applications outside of this vertical? So, and maybe in which other areas do you see the most potential for it currently?
I see the most potential in some very simple applications, as were mentioned before. Screwing, gluing, for instance, or manipulation of small parts. I see also advantage that the people who are working with these collaborative robots do not need to be specialists, because the interfaces are simpler. The interfaces are very much closer to the phone, our phone tablets, than to the classical robot controllers.
Thank you, Marko. And let me go to our next speaker, Niko Herakovič, who is a professor at Faculty of Mechanical Engineering and head of laboratory for handling, assembly, and pneumatics. So, Niko, the word is yours.
Thank you very much. I hope you can see my screen. So I will briefly introduce the Smart Factory Demo Center that we have built in our laboratory in the past years, together with, of course, some supporters from industry, especially from Collector, and also SREEP and, for example, other partners. In general, just briefly about the Smart Factory, we see that it's a quite complex system. We have heard in previous presentations and saw specific technologies that we use here in this Smart Factory. So what we do, we try to bring them together to get some synergy, and have to bring them to communicate with each other as a whole. So this is the way how the Smart Factory works. And here I would, of course, I would say something about logistics that is usually, I think, the field that is neglected a little bit or forgotten a little bit. But in the Smart Factory, it's a very, very important part. And we have to take care about also these logistic systems. We have been told about big data, about how important these data are and how we get those data. And when we go to such a huge system as Smart Factory as a whole, then we have really a lot of data. So it is very important here to now distinguish what data are good, what data are bad. And what we have done in our Smart Factory Demo Center, we went away a little bit from this big data, because it could be for operational working of such a system could be a problem. So we went more into the direction of distributed systems, or let's say edge computing. So that's how we do. We try to solve. I will say this later, a little bit more later on about the way how it works, but it works more on the edges. Let's say try to solve a little bit local problems. So this is our smart factory demo center. It's not such a huge in physically because we don't have place and space where to put it, but it's huge in the content because it has everything a smart factory should has, also including this manual workstation, because we believe that in the smart factories also manual working station will be important, and Industry 5.0 is talking about that. So this demonstration center is meant for research and development in the first place, because we have to develop new technologies, we have to test new technologies, and we can do this in the demo center. And also for students, education and training of students, students can work and learn about all these technologies in the smart factory and how it works. Then also for project work and testing field for industry and education and workshops for industrial partners. We do this together with three factories of the future, and also with the Chamber of Commerce, we organize educational workshops for our industrial partners. So what is the specific of our approach? We believe that digital twin of every part of the smart factory, every technology, every process is the backbone of the smart factory. So we must have all the processes in the virtual environment, and we do have so. Then we must have also the feedback from the real system, so that we get every signals from the real system directly to the digital twin, and with the digital twin we can see immediately in real time. We speak here about milliseconds, what is going on in the real system, and we can adapt the real system, or we can improve the real system that it works better. And before we improve it, we test these scenarios in the virtual environment, and when we get the good result, we sell it back to the real system. Of course, we cannot do it by ourselves as human beings, but for this purpose, we use artificial intelligence that is running behind. And artificial intelligence, we call this digital agents. We have a lot of digital agents. They are communicating among each other, and they are communicating with digital twin. And digital twin is actually a calculator for different what-if scenarios. And when the best scenario is here for the real system, then we send this information back to the real system. So here is the edge computing very important, because if you want to be fast, if you want to not to have too much data, then we must make a lot of edges, let's say, or distributed systems where digital agents are put in. In every edge or in every distributed system, there is a digital agent one or many digital agents, and also digital twin, and they are dealing only with one parameter or probably two parameters, and they decide by their own what to do, and they send to the central system only those data that are necessary for the central system. So this is the way how we work, and this demo center is really working well, and we try to distribute this knowledge, or we are working this direction together with our partners that you see here. We transfer the knowledge in all those companies that are listed here, not completely, but partially. But the most known is Yaskawa, as I already mentioned in parallel section, in panel section, where we use these technologies to make or to plan the new factory, robot factory, in advance in the virtual environment. So thank you very much.
Thank you, Niko. So I often feel, at least was my experience, that manufacturers sometimes are quite intimidated by the whole Industry 4.0 concept. What would you say are maybe the kind of smaller parts of the manufacturing process that are maybe the easiest to start for implementing technology related to Industry 4.0?
Well, I think always it's very important to find out a pilot project. It doesn't matter what. It could be a cell. It could be a small line. It's not good to start with the whole company. Even if we do so, sometimes we start with the whole company. But usually it's better to start with a small line or a small system. And there you can learn quite a lot how it works. You can learn about these new technologies, implement these new technologies. And also you can understand each other. This is very important, is understanding each other, because this is one thing that is here in these digital technologies, a huge problem if you speak, in one direction, another in another direction. So we must understand each other, and data are very important. We must learn how to get data, how to get the right data, as it was said previously, not every data, but the data that we need. Well, when we're talking about digital twin, then actually we need every detail of the process. And here we must know also the methodology, how to describe the process correctly in the right way, so that we get the real picture of the process in the digital environment, and we can make a model then and connect those together. And as I said previously, this edge computing and big data, these are two things that are, in my opinion, very important. We are speaking at the European level and also Slovenian level about artificial intelligence and supercomputers. But small companies and small and medium-sized companies don't have the opportunity for that, I think. And that's why edge computing is so important for them, because they can solve gradually, and they can start with small pieces, and then they can build on.
Thank you, Niko. And let us go to our next speaker, Aleš Mihelič, who is an innovation leader at company Gorenje. Welcome, Aleš. The word is yours.
Welcome. Thank you. Let me share the screen. So I hope that you see it. There's a presentation. Maybe before starting to introduce what we are doing in Gorenje, maybe I should tell that we in industry are very much interested in the artificial intelligence. We are aware that actually this is helping us to make things faster, better, but on the other side also actually is simplifying the life of the users. The problem which we see is that sometimes these technologies are relatively expensive for the end user, not so much for, let's say, for the improving process in the company, but to the end user. And actually what I will show in the continuation will demonstrate that that you could come also close to the market with the artificial intelligence also in some cases. As I mentioned before, we in Gorenje are actually simplifying the life of the users in several areas. One of them is laundry, where I am responsible for developing of the, let's say, new functions for the washing machines. And what we want to do with this new functionality is actually to simplify the most tedious work, which no one actually likes at home. This is washing laundry. So we want to make it automatic. I'm personally convinced that in, let's say, 10 years or 15 years, more or less washing machine had to do really automatic, so that this means that they had to recognize what kind of the laundry we have inside the washing machine, what kind of the color is inside, and then also to propose or to execute the proper washing program in order to finish, to have the end results, which is properly wash laundry. So we are here actually using the technology which is used for the space application. We got the idea actually by the Earth observation program, and this is why we actually also aligned with the company spin-off from Maribor University Skylabs, which probably know now that they have the in-flight operation of their microsatellite. And we are using the same technologies actually, the space technologies. This is more or less, let's say, spectroscopy in two areas. One is in the visible light and near infrared or shortwave infrared. And with this, we could also, what you see here in the picture, we could recognize different textiles like cotton, wool, silk, viscose, polyester, polyamide, and polyacryl nitrile. So you see that the curves are different, and now the challenge is how to bring this actually expensive technology to let's say to appliances like washing machine, where we have relatively low margins. So with the procedure for the washing should be very simple. So this means you put some pieces on the sensor. These sensors will detect actually what kind of the material is in the material. We have done a lot of testing. So our base sample is more than 2,000 different samples composed of one component, 2 and 3 components. And so it was a lot of training done by the colleagues at the faculty. And this also results that we have very good accuracy also in actually the results, so that you see that here we have more than 90%, 98% actually for the detection of the composition of the textile. In between, we have also recognized by using this technology that actually the fabrics and the labels which are in the clothes which we are buying are not always correct, that also some of the producers are misleading the consumers at the end. And this also results then in the, let's say, the fabric after the washing which shrinks or lose colors or something like this. So the challenge, as I mentioned here, we have the technology which normally costs in the amount, let's say, of several thousand euros, that we need to bring them down so that we could put them in, let's say, 300, 400 euro expensive washing machine. So this is a real huge challenge which we see, and I think that together with some simplification which we actually put into together with the colleagues from the faculty, we are very close now to this. So we are actually now discussing already the, let's say, the use cases where this application could be first launch, because we are aware that if we start with small quantities, then the technology will be very expensive. So this is why we need to have, let's say, start of this new functionality in a relatively large community.
Thank you, Aleš, for the presentation. So one question, and I often see that companies face in relation to implementing AI, is who should actually be the developers working on those systems. So I'm wondering, what is the approach that you take in Gorenje? Is it more like existing engineers with deep domain knowledge adopt new approaches, or are you making like specialized hires in this area?
No, we here actually we are aware that we are too small. We have only 300 researchers in Gorenje, and we have a lot of products and a lot of technology, and a lot of knowledge is going let's say getting to on the, let's say, on the plate. So we are more or less relying on the outside companies and the institutions to help us with the development. Of course, the key knowledge maybe in the content side is from our side, but the rest we rely on the outsourcing. So this is I think that we had to be only the integrators in the company. So this is why I think that very good cooperation with the knowledge institution is of crucial importance for the future. We look for this knowledge all over the globe, so not only in Slovenia. We had to where we are glad that we normally were able to find, let's say, proper partners.
Thank you, Aleš. Now for our next speaker, it's Lucija Brezočnik, who is a teaching assistant and researcher at Faculty of Electrical Engineering and Computer Science at the University of Maribor. Lucija, the word is yours.
Thank you very much. I hope you can see the presentation.
Sorry, Lucia, we cannot see it. Maybe try to share it once more.
Okay. I think now it should be.
Now we can see it, yes.
Okay. Sorry for that. Thank you again for the introduction. As previous speakers also pointed out, we really live in an era of big data, where enormous volumes of data are emanating from various digital sources. And not only that, easy data acquisition with automated data collection tools and databases with practically no space limits only contribute to that. But what is the real outcome of this? Well, data which is rich but information poor. But nevertheless, one would think that having such big data is a blessing, but quickly he or she would realize the underlying challenges while analyzing such data. So here the traditional data processing tools fail. So those are also the challenges that we are tackling in our institute. And globally speaking, we can say that the vast majority of the research that we do is with unstructured data. So here we can see one example of text analysis that we did. We developed a data analytics tool that automatically identifies and collects information about business investments. Artificial intelligence here was used to determine the value of news articles and to extract the key information from it. We are doing also a lot of research on the source code analysis. Here you can see fingerprints of two open source libraries, and they're overlapping here in the middle. Sadly, still very active COVID situation gave us data where we were able to distinguish between COVID and ordinary pneumonia. The results of this were later on also approved by doctors. And in our blockchain lab at the faculty, we are doing a lot of research on blockchain technologies. Here we can see one example where artificial intelligence was utilized to find anomalies in the blockchain transactions. But lately, we started working more and more on the sensor data. I'm very happy to present you this analysis on the electricity consumption that we did. We processed over 600,000 measuring points with a total number of more than 13 billion measurements. Real big data story. And for them, we found common similarities, patterns, clusters, provided prediction models, etc. But speaking of sensors, what about wearable technologies? Wearable technologies are nowadays presenting one of the most exciting data sources. And let me present you one of the recent solutions that we developed with partners, medical apps. So the goal was to gather biophysical parameters to determine the pilot's psychophysical condition. And the data acquisition was done via smartwatches that you can see here. So the project idea, in other words, was pretty much to clearly divide between physical and mental stress. And why is this important? Well, legal restrictions are saying that pilots must rest enough time before flights just to be mentally and physically ready to fly. But what happens, for example, if a pilot was up all night before his flight? That would for sure affect his psychophysical condition. But now knowing the problem, we can actually provide the solution and run it on smartwatches like this. What are the requirements? Well, the models are not black box and that are at the same time accurate and explainable. Thus we created models that could be easily run on smartwatches that we know they're having lower processor capacity and shorter battery life. So our methods were able to separate physical and mental stress with around 98% accuracy. And with fast tempo of living, where are the options to utilize such ideas? So we can use such watches on truck drivers, miners, athletes, at the end of the day, also to doctors who are giving their best every day in hospitals. So what can I say to conclude? Finding parameters, informative features, anomalies, etc. in big data is a super, super fun task. And as presented, you can see that it is not just academic thing that we are doing, but something that companies worldwide wants to implement, and just to have that significant competitional advantage on the market. So yeah, let's connect and have fun while discovering something new. Thank you.
Thank you, Lucia. So this area of this biophysical sensors, it's kind of difficult to think about it without also thinking of potential abuses of such technology or privacy concerns. So maybe you could shed some light on those questions.
Yeah, so I think I can answer it in two stages. So first of all, we have to understand the problems of gathering such data. We all know that like smartwatches and other wearable technologies are not always very useful or having this or giving this data that are like consistent, easily pretty much gettable. So we have first to think about, okay, what are the best options to gather info from smartwatches, or maybe some other ways of maybe sports Bluetooth connectors, stuff like that. But on the other side, when you have this data prepared, what can we do to protect it? Well, we have in our institute, we have special laboratory who is doing for that, and we are just presenting different models. And so we are having this security model in the middle, but to get more in detail, I suggest that we can maybe talk a bit later in the discussion panel, just to not take too much time from the last speaker.
Okay, great. Thank you, Lucia. And yes, indeed, now we arrived at our last speaker, Matej Guid, who is CEO and founder of AI company InstaText, and also assistant professor at the Faculty of Computer and Information Science at the University of Ljubljana. Welcome, Matej. The word is yours.
Thank you, Boris. The idea of InstaText is to help us to write like a native speaker. By using artificial intelligence and language technologies, InstaText automatically improves our English text and creates recommendations and ideas how to improve the content and make it more readable and understandable. I'm in artificial intelligence for more than 15 years. In 2010, I was nominated for Best PhD dissertation in Europe from the field of AI, but I didn't receive this award. Maybe it wasn't written well enough. We'll never know. But the general problem in academic writing is to write clearly, to write concisely, effectively, and to be understood. And we all know that effective written communication is the key to success, especially in academia. And over the years, many tools emerged, like spell checkers who are they're in a way perfect, but not address the right problem. Then grammar checkers who stick too much to the original text and they don't really correct our non-native speaker phrases. well enough, and translate tools are getting better and better, but we know that the English then needs to be improved. So there is a missing tool in particular for non-native speakers. Now, academic writing, like writing articles, is a process. And in this process, there is a very important phase of word editing, where we want to improve our text, to write it more clearly, add more details, and maybe change the structure, write more efficiently, and so on. Very important phase where we have no real-time help available. We cannot address anyone at that time. So the idea, like a few years ago, in our ideal world, we would have a tool that would rewrite each paragraph in a way that native speaker would write it, like a competent native speaker who is good at English. But we still want to maintain control over our text and be able to accept or reject particular suggestion. And here we are actually watching the screenshot of InstaText. Now, the main idea is to improve the readability and the understandability. Like, for example, is more connected between each other in the second and third row is typical Slovenian English. And InstaText would correct it to is strongly interconnected or tends to be linked in this particular case. So it helps us to write clearly, accurately, to produce high quality, efficient sentences. And this happens just in a few seconds, probably about 3 seconds. And it helps us to also improve our understanding and written communication of English in general. So basically it looks like Google Translate, except, well, we put some text in the window on the left, we get rewritten, improved text with marked changes. And compared to grammar checkers, it offers far more suggestions. It gets you get a better overview how the text should sound, and it's able to rewrite some parts of the text completely. So it's about readability, about understandability, and therefore suitable in various domains, including academic writing. So currently we have like more than 15,000 active users all over the world. Customers from I would say 24 countries. I think the number of customers at University of Ljubljana alone is larger than 2,000 at this moment. And we're also startup of the year. This is an interesting statement from a student from Berkeley. I find InstaText very helpful, makes me much faster in writing paper. I'm a perfectionist, like we all are in writing papers, and usually spend way too much time finding the right words and making sure that the sentences are easily readable, even if the concepts are arbitrarily complicated. That's usually the case. We have to explain difficult concepts in understandable way, and then therefore InstaText makes her life easier. Maybe if you allow me, I would show a short video so that you get a better idea about how InstaText works. So that would conclude my presentation, and I invite everyone to try the tool at InstaText.io.
Thank you, Matej, for your presentation, and I can personally confirm that InstaText is working really great, and I can recommend it to everyone. But I will ask you one question now that I think most of co-founders in AI companies have to deal with at some point. So obviously, in a way, when you're developing such a tool, you are also competing against companies that have that are wielding incredible resources, both in manpower, computation, and so on. So how do you see the risk that tomorrow or 2 months from now, you know, just a big model produced by some of those big players could you know, potentially make InstaText obsolete? And maybe what is your vision in such cases? Where would you want to take your product?
Well, first of all, I don't think about it at all. I would say we are doing this with great passion, and we like to improve the tool as much as possible. Now we are developing some personalized dictionaries, additional language settings, and various enhancements that will improve user experience. And of course, it's possible that such tools emerge, but we are building a brand, and people love the tool. I would say there will always be some part of users that will stay with InstaText, and the base of users will grow.
So basically building a quality user experience, and this matters a lot, sometimes more than the technology itself, right?
Yes, but I would say learning very fast matters a lot. I would say I'm doing lots of online courses now on growth, product management, on digital marketing, on all kinds of aspects to grow a company. We have a very strong team, and I'm very proud of our team. And we have to do the right stuff at the right moment. So this is crucial. Yeah. It's a lot about learning fast.
I agree. Thank you, Matej. So now we've come to the end of our list of speakers, and before we continue with our panel discussion, we also have one question for the audience, just to maybe assess the general sentiment that you in the audience have towards AI. So I would ask Ine to maybe display that question. So basically, how do you see AI as something that is overhyped and will under-deliver in the future, something that is comparable to all other technologies like IoT or AR, or whether it's something truly revolutionary that will really transform the world? Okay, we'll comment on the results a bit later. Now let me start with our first question. So to all the experts that are part of the panel, you know, we all know that it's sometimes quite difficult to predict future trends in AI. That we are often surprised by something that happens. So my question is whether you have whether you were recently surprised, basically, that something happened that you did not expect in the field, that maybe changed your perception about where things are going.
Maybe if I can start. So there, in the area of AI, and particularly in the language, there's a really huge amount of things going on every day. And I think that nobody can follow all the papers anymore. And the conferences can grow like exponentially tenfold. So I think that this all speaks about enormous interest in AI, but also of enormous development. So even though the winter is coming, I mean, that winter is going to be different like the previous winters were.
Yeah, I mean, I would agree. I would confirm that this is happening in computer vision as well. So you can't compare, let's say, the conferences 10 years ago or now. Like you really have like this exponential growth, well, until this spring, right? In the participants at conferences. And also when you see like the sponsors, not only the participants, like the sponsors are basically fighting to co-finance these conferences and to get in touch with the researchers, PhD students, and so on. So I mean, this is a consequence. This, let's say, it's hype, right? But this hype is supported by the results. So at least in computer vision nowadays, I don't know, 90 or 95% of solutions are driven by deep learning, and they achieve significantly better results than they did before deep learning era. So I really don't expect like AI winter to come in this sense. Of course, we have to calm down a little bit. So I also see usually like we researchers are more realistic, more conservative in somehow predicting the future as maybe some users or don't mention journalists, right? But we need to be realistic. We need to be aware of pluses and minuses. We need to be aware of requirements that such methods actually require. But considering all these ingredients, I think that we can, I strongly really believe that we can make a huge progress in many areas.
Maybe I would also mention if you the openness of the whole community. I think there's, I mean, it's becoming really a standard that people publishing a paper would also publish their code. And this is really helping the, let's say, the growth of the community and of the research field as a whole. So this is something which it's not so common maybe in all the areas, but definitely it's common in computer science and particularly in machine learning.
So maybe on this point, Mark, how do you see this this trend in Slovenia? I mean, regarding you know, open sourcing code. I know that you were a contributor personally to quite a few libraries, but overall, do you also see this as kind of a general trend in Slovenia research community?
Well, I think it's more community dependent than it's not so general. I would say that, I mean, when I started working on in the AI, I saw that basically this openness really helps. So people who were like jealously covering their own research results and code, in time nobody knew about them, and people who were more open, they sort of succeed. And I think that the community saw that, and we humans learn by copying. That's how it works.
Maybe I could add that for this artificial intelligence, also some other communities had to be involved. Here I'm thinking mainly about responsibility for the results of the decision of the systems. So we know that, let's say for the time being, even in Tesla cars or let's say automotive driving, in principle, it's not allowed to drive with artificial intelligence. So it's still the user at the end who is responsible. And here, in our case, also we have a lot of dilemma. For example, what if the system will not work properly and we will spoil, let's say, the clothes of the consumer or something like this. So this is our responsibility of the producer at the end. That maybe this is also what I said in my presentation, that it's different, that it's easier to implement the artificial intelligence to help you, because then you are bearing the results, then put it on the outside world so that all the others are using it. And for this, I think that also now with the merging this, let's say, share approaches, circular economy approaches, then also this question of the responsibility and assurance could be easily solved. So for example, if you just go to the autonomous driving, I'm convinced that if the Tesla will be insured, then you as a person, you don't need any more personal insurance for driving. So you just sit in the car and go. And this is why what also the legal part need to be complemented to the technical work.
If I may add something to this artificial intelligence, I believe that there are different levels of artificial intelligence. That's what we are talking nowadays, especially in companies and applications, is quite low-level artificial intelligence, in my opinion. And this really real artificial intelligence that will decide by itself, that will not have any control anymore, I'm afraid of. But that's what we are doing, especially in my laboratory and what we're doing in companies. We cannot do anything now, almost anything, without at least a little bit of artificial intelligence behind. So let's say deep learning, or we are using quite a lot also, trying not to use artificial intelligence, but to go to heuristics and meta heuristics and so on. So I think without artificial intelligence, it's difficult to solve problems, because when you come to industry and they have such a complex problems, and they want us to solve, I don't know, difficult things that when you try to think about it's already difficult not to do it. And if you don't use such new technologies and artificial intelligence, it's not possible to solve. So, but still, I believe this is low-level artificial intelligence.
Yeah, thank you, Niko, for pointing this issue out actually. And so the last question that I wanted to pose, but maybe I will pose it now, is that recently there's been quite a bit of talk about something called the scaling hypothesis. So it's basically a hypothesis that potentially we might get to really much stronger AI systems by simply, you know, taking the existing algorithms and feeding them a lot larger quantities of data and giving them available a lot larger quantities of computation. So my question in this regard would be, of course, what is your take on it? And maybe if you consider some of the things that you are working on, how would it change if you had like 100 or 1,000 times more data and compute available?
If I may first answer to this question. So we can look at this question from two sides, basically. Like, one is like the positive one. It's definitely more data you have, more information is hidden in the data. So better models can you make that produce better results, right? So this is no question. Is you have more qualitative data, right? Not just any data. This is also another question. But regarding this question, often we get this question like in connection to what if AI prevails or something like that, right? Because it's getting smarter and smarter and so on. So regarding the question, I'm very, very conservative, I would say. So all the problems that we're solving now really depend on data, but this data is more or less structured. Even it can be less structured, but still is somehow encompassed in some problem that it tries to solve. And the model that we create solves that particular problem and not a general one. So with respect to this one, I believe that the models will be more robust, but still we are talking about the data-driven solutions that are based on that data and not about some general AI that would go beyond that. So I think that we shall not be afraid of having super intelligent AI, whatever, that will overcome us. But the truth is that these tools are becoming smarter and smarter, right? Using our algorithms and more data they achieve. So we need to deal with them intelligently and with a good purpose. But that's the other story.
I can add to this. I can confirm this. Data are very important. That's what we do all the time. But as I mentioned in my presentation, there are two approaches. One is central approach, when you need a lot of data and supercomputers to solve or to extract something good out of those data. And I think for small and medium-sized enterprises, this is a huge problem and it's very expensive. That's why we started this edge computing approach years ago. And here you don't need, of course you need a lot of data, but you can solve this locally. So you need just one parameter, one data, and you can solve it immediately at that let's say position that it appears. So I think this is for small and medium-sized enterprises quite a good approach, and it showed in our case that it works very well.
I would like to add something, like with these writing enhancement tools, the time to publication becomes much shorter. People are writing faster. More and more articles are emerging. So there is a lot of knowledge about humanity in general. They're already on Google Scholar and elsewhere. And machines will sooner or later read this and learn from this. And they will become smarter and smarter. And it's clear that they will become smarter than us and they can manipulate us then. It's not a question. It's just a question of time.
Well, this is where I strongly disagree with Matej.
Yeah, I think that actually, at the moment, we still don't, I mean, we are increasing the amount of data, we are increasing the amount of computation and power, but we haven't really made a large progress in the terms how we structure the knowledge, how we, let's say, how we build the reasoning mechanism, how we build the common sense knowledge mechanism. So all these technologies are still way beyond, and we don't even understand how we understand. So, but if I can add, Boris, maybe you were also alluding to the models like GPT-3, right? Who try to, let's say, generate the text, and it looks really intelligent. But if you want to use that text really for something, let's say, summarization of financial news, you are not sure that it will be correct and so on. So we will have great new applications of these huge piles of data, but we still need a lot of reliability. And as Aleš Mihelič said, if you want to have reliable mechanism, if you want to make AI more robust so that self-driving cars will do, so that the washing machines will operate, then we will have to build something which is even better than humans, not just as good.
Yeah, yeah, Marko. Indeed, I was thinking about models such as those when I asked the question. But you know, the part that was personally maybe the most interesting to me with such modeling is that the question of an emergent property, basically. So that you know, some properties of the models emerge that you might not actually initially, when the initial architecture was developed, think of. Like in case of these language models is the so-called meta learning. And you know, through some of this conversation, I remember how it used to be when working with images and text data. I mean, there was really you know, before deep learning became popular, it was really hard to develop all those you know, attributes in those areas by hand, and people were not, you know, that optimistic if someone asked them about the near-term future of what would be achievable. So, you know, I'm thinking about and maybe this is also as part of another question. For example, like it is with things like global warming, right? When we have to be, in a way, we have to be ready for all kinds of scenarios happening, right? And I mean, even if the likelihood is, you know, 3% or 1% that something like that could happen, right? I mean, shouldn't we be at least considering it and potentially be doing something to get ready for it? So anyway, my question is basically, are you worried with anything in relation to development of AI?
Well, I would say it's about humanity, how we are organized. We are competing with each other, and also this question about global warming. We are not collaborating; they are still competing. So it's too expensive for some companies or some states to participate in this prevention of really bad things that can happen there. And it's similar with AI. It's not about the technology, it's about humanity and the way we're not aligned on a global scale. We just compete with each other, and this is the problem.
Maybe one thing which, maybe one thing which really we should be worried about that we are not is that huge amount of research money going into the military applications of AI. I think really, I mean, lots of researchers have signed, we have signed some petitions, and we have signed some, let's say, moral obligations that we will not develop military applications, but this is going on. And I mean, we could be really worried about that.
Maybe Lucia and Žiga, you are working with, I mean, you presented some topics in your presentations that I thought are a bit controversial in the field of AI.
Maybe what I wanted to point it out before when we were talking about data and working with industry, what I realized is that usually, let's say, smaller companies who wants to implement some AI in their companies are just giving data, and they said, okay, this is data, now do some magic. And like it was pointed out before, we really cannot just take data. We have to pre-process it, we have to prepare it, and then we can actually do something with the data. And I think this is something that recently I started seeing this progress, that it is just not, here is a database, now do something, but also that companies are starting to get, now I'm talking about small companies, not like the big ones who are also having some know-how in the company, but they're starting to realize that they have to do also some pre-processing, or at least do some explanation of the data, so that we can actually utilize some models and provide good results.
I saw a question if from somebody from Mr. Mihelič, I think.
Yes, I wanted just to point it out. So
in chat, yes, it's an interesting question, and yes, we spoke a lot about these problems that are exposed here. Last year, I organized in the Cankarjev Dom, I think, discussion about that, about ethical problems. For example, that there was one guy from France is really expert in this, and we discussed a lot also in previous discussions about that. For example, robotics. If a robot, if artificial intelligence will really be developed in such a way that will develop itself, that we will not know anymore how these algorithms work. So if it comes to this point, then, for example, a robot could start working on its own way. And who will be responsible if a robot does something wrong? We will put the robot into the jail and such things. So this is a huge discussion. And punishing, how we will punish him. For example, if we want to switch off the robot, and we cannot switch it off because it will be artificial intelligence somewhere in the internet, and if nobody will switch off, for example, if only one computer stays in the internet, then he can go into this computer and has there still something where he can work on and so on. So these are huge questions, and these are ethical questions that we should also discuss. But I don't think that we are still on this level, but it goes in this direction.
Yeah, so sorry, yeah, I was just saying that soon we will run out of time, and there is one question more that I would like to ask, but go ahead, Daniel, maybe a quick.
No, I said that I really don't see that we are going that direction, right? So we are making a huge progress on machine learning, on let's say pattern recognition. So in finding patterns that are there and learning on the base of previous patterns that happened. To something like happen something like that would that the robots would endanger us or something like that. You really need to make a huge progress in general AI, and I really don't I don't see that happening. But we need to be really aware of dangers, all the dangers that can emerge with having powerful machine learning systems in the hands of people, right? So that's the other story I completely agree with, and we really need to consider all the ethical issues and so on.
Žiga, I think you, yes.
Yeah, I just wanted to relate to Jonas's question. It's not only the problem of explaining decision models, the underlying principles, but it's also problematic from the biometrics perspective. We are using mobile devices, and that means, laptops, mobile phones, using fingerprints. I'm also using that, also face recognition. But the question is not only that we don't know how, the decisions are being made, because in that case, that is not that important. But the problem is also the data underneath it. If you can imagine a really bad system where, your full fingerprint, the full raw sensor data, is being sent on a server somewhere, that is a bit scary. Or, your face, being processed on different locations, different servers, and so on. So, the authors of those systems can say, oh no, but we are doing some sort of feature extraction, we are doing some sort of analysis and then storing that. Yeah, that's okay. But since we don't have open source solutions. We don't have, you know, open solutions. Let's say we have no guarantee, no insurance that the data is protected as it should be. And that's another issue or problem, I think larger than, you know, having some super robots, you know, in some future. I think that's an issue that we should be doing right now, not in 5 years or 10 years. So that's what I wanted to add to Jonas's question.
Or maybe Lucia, and then let's go to
answer. Sorry. If I try to answer the question as well, in our research works at the university, we always try to have explainable models and always try to somehow connect domain experts with machine learning methods in order to obtain methods that are aligned with experts and at the same time explainable. But the problem is that sometimes performance is important, and then you cannot afford any more explainable models. And this is, I guess, the issue.
Okay, so due to time constraints, we really have to move to our last topic. So first, let's take a look at the results of that previous question that we gave to the audience.
And do we have results of the first poll?
Yeah, sorry.
Well, we can see that the audience really is very optimistic when it comes to AI technology. But of course, I'm not surprised that there should be some maybe bias for people who decided to attend this parallel session. But anyway, if we move to the last question, so you know, in Slovenia, I think we are often very fond of talking about our achievements in AI, and also maybe, you know, how we are positioned compared to some other regions in the world. So, you know, but I think that if you want to get better, we really also be a bit critical in a constructive way. So, and one question is, of course, if we have enough people with the right skills to make the most out of AI, especially when we move from laboratories to maybe more applied settings in companies. And I've made a really very quick research about that on LinkedIn. But you know, before I show it, maybe let's ask the audience this question about how they see our position, so Slovenia's position in AI compared to the rest of the world. So, okay, so now I will show you this table that I've created. Just a moment. Okay, can you see it?
We cannot see your screen, so maybe just try to share it once more.
Okay. Can you see it now?
Yes, we can see it.
Okay. So what I did was basically I took the skills in TensorFlow and PyTorch, which are kind of the libraries I think we would probably agree that are most often used in AI development today. And I compared the number of people with those skills to the ones who reported they have a skill in C++ programming, which I think is a good representation.
Boris, sorry to interrupt, but maybe can you just zoom it a bit, because it's really small. And
okay, okay, sorry about that. Let's see if I can do that. Is it better?
Yeah. Thank you.
Yeah, so basically I just took that number of, you know, people with let's say TensorFlow skill and divided it with skill in those with skill in C++, and I got this ratio. Of course, that's multiplied by 100. And you know, we can just limit ourselves to EU countries. And it's interesting because at the top of this list, so the ones that have the best ratio are such countries that are often mentioned you know, as being especially strong in AI, like maybe Finland, Germany, Estonia is also very successful in digitalization and so on. But Slovenia here is quite towards the bottom of that list, and also the same also with the PyTorch. So my question would be, what is your take on this? How do you think we are placed in regard to the skills that people have? Do we have enough people with the right skills, and maybe what we can do about that?
Well, these metrics are, if you take another metrics, you'll probably get another result. So, but speaking from general perspective, at our faculty, I'm pretty sure that machine learning and AI as such is quite well represented. And Zupan mentioned data science master program that we started just last year, and I'm in the panel before this session. And I'm completely certain that this is one of the best data science programs in not just near vicinity, considering the quality of the program, not the number of students. So from this point of view, I think that from the educational point of view, I think that our students are exposed good enough, well enough in these topics. Then the question is how this translates to the companies. The question is, how do we collaborate, right? How do we adapt to the companies, to the needs of the industry, and how actually industry sees that as an opportunity, right? But definitely there's something is going on, and I don't think that we are. I think that this is not, even if when I know a little bit about other countries and their position of, let's say, AI in their areas, I wouldn't agree with this metrics as a general one to show how well are we doing in that. So, but of course, there is a lot of room for improvement, as we can say.
Maybe if I can add a few words. So maybe, I think that we have, let's say, good students, good, let's say, researchers in AI, but we, as a country, we are failing maybe in the general education. So we don't have enough people who would maybe be technically educated or educated in natural sciences. So we really don't promote these sort of values. So this is maybe a larger problem in our, let's say, in the whole society. The values which we put on different, let's say, areas of science, areas of social development, and so on. So we don't promote enough, maybe enough of the also of the entrepreneurial, let's say, spirit and so on. So this I see as a larger problem than what you mentioned, Boris.
Yeah. Also, a bit of my take on that is that one thing that we really should strive to make better is to find ways to attract more women into ICT field in general. Because I think also in this regard we are lagging quite a bit. I think we are maybe at the also in that perspective bottom 5 countries in EU or something like that. I saw some results a few months back.
If I might jump in on this question, as IEEE Slovenia Women Engineering Chair, I totally agree, but I think the main problem are not the faculties, but we have to change something in the primary schools, and also then in high schools. So I think we really have to point out that like programming, technical studies are not just for boys, and we just have to move away from this stereotype, and we have to start working on that from early age. So I don't think faculty is the right place to start with this. We really have to start in young age to change this stereotype, because we can see that from statistics that primary schools are doing, we can see that the girls are on average much better than boys in mathematics, programming, stuff like that. But later on, they just decide that this is not, their calling, so to speak. So we really have to work on that in early age.
Any other thoughts maybe on this topic? If not, maybe we could show also the results of the poll.
If I just might add, right, because you're calculating ratio between, so you're just considering the TensorFlow and PyTorch, which are like deep learning techniques, and this is just a part of everything. I strongly believe it's the biggest part currently, right, of the AI as such, right, but it just tells a part of the story. But I'm quite certain that in next years we'll have a larger proportion, because we're just starting to introducing this topic more seriously in our curriculum in a recent year. So I'm pretty sure that in a couple of years this will change.
Oh, I mean, of course, I'm also quite optimistic of the positive trend, but you know, it's a question whether we can accelerate this some more. I mean, like maybe if we don't get enough people from, you know, trained from university, maybe we can do as a country more in the area of upskilling existing workforce some way. So this is maybe some idea how to enlarge that ratio. And yeah, of course, I saw some questions from the audience. Yeah, it's basically a ratio between the number of people reporting PyTorch and number of people reporting C++ skills. So in this way, it normalized, of course, but I'm not pretending that this is a real scientific study, just maybe a quick insight that everyone might get by looking at some data that's available to everyone. Okay, so maybe if we could see the results of the poll.
Yes, I'm going to reshare it. So.
Okay, so yeah, maybe not that surprising, but of course, released also some optimism here as well. Anyway, I think we are quite over the time that we've had. So it was a real pleasure for me to share this panel. I hope that the audience got some interesting insights into AI. Thank you to all the panelists for your presentations and also participation in the conversation, and also to the audience for their attention and also some nice questions. So thank you.
Thank you.
Yeah.
Bye-bye.
Thank you, boys.
Thank you also to you, Boris, and all the participants and attendees. So I think we said hi to AI very successfully today, and maybe we should consider to change the country slogan to AI Feels Slovenia, considering all the great insights and debate and projects happening in Slovenian research labs. And I think we can agree that AI is not only a very exciting area of research, but is and will continue to be an important aspect of our very near future, and it will continue to shape our progress. If you want to continue this interesting discussion, we can do this on in Whova. The Whova event platform enables you to meet the speakers, attendees, and also us organizers. If you want to chat on this topic or meet up, share some more articles, please do. There is a link in the chat box which will guide you on how to download the app if you haven't done so already. But most of all, we hope you enjoyed this event. Your opinion matters to us, so please also give us our feedback. We would be delighted if you would join our next events happening on the 19th of November is the Sustainable Future panel, along with 3 parallel sessions. Then we also have some exciting content for students. The Google workshop is happening on the 23rd of November. We will close the UNI.MINDS Festival with another exciting panel called Future Society on the 24th. If you want to find more info about any UNI.MINDS events and session, go to the event website. You can find it in the link in the chat box. But for today, that was all. Take care, keep an open mind. See you at the next event, and goodbye.